Yes. Good morning, good afternoon, ladies and gentlemen. Welcome to our next edition of the VDMA Textile Machinery Web Talk on our way to ITMA. As you know, ITMA will start on the 8th of June, so it's in a few days. We are all very eager to know what will happen then in Milan. As you will be aware, you can ask your questions during this web talk using the chat function. Our colleague Nikolai Strauch will have a look on your questions and then we will try to answer them later on. You will also get the presentations 1 hour after this web talk, and also the video will be recorded and published. But today it's about data-controlled textile production and how to make money with it. I must say that the VDMA member company Mahlo has been on stage together with VDMA at many occasions. We've been together in many countries. However, I'm really eager to know what kind of innovations they have in the pipeline for ITMA. So let me warmly welcome again many participants from all over the world, from the textile industry, but also from textile machinery agents, from brands, fashion brands, and so on. It's always a pleasure to have you here on stage. My name is Boris Abatschiev, and now I kindly ask the colleagues from Mahlo, Thomas Höpfl, Stephan Kehry, and my colleague Nikolai Strauch to introduce themselves. So please join me here on the stage. Who makes the beginning? Thomas?
I make the beginning. My name is Nico Strauch. I'm also working for VDMA, and as Boris already mentioned, I'm today in charge for the chat function. If you want to ask questions, please use the toolbar on the right-hand side. And now Thomas and Stefan, please.
Okay, a warm welcome from Bavaria, from the new Mahlo Media Center. My name is Thomas Höpfl. I'm since 28 years now with Mahlo. I was in former times responsible mainly for the Asian markets, and since 2007 I took over the position as a sales director of Mahlo, and so I'm responsible for the sales activities.
Hello and servus from Bavaria. Also from myself, my name is Stephan Kehry. I'm responsible for the product management here at Mahlo, especially for the textile fields. And together we are the
Energy-Hunters.
So today what you can expect is that we are presenting you all the different tools that you can use to save energy. And why is it important to you? Because I think there are a lot of fields in your production that are not yet covered. So if you are really honest to yourself, there might be some potential that you have missed so far. We're gonna show you one of them. And that's valid actually for everybody, for the workers, the operators, the production managers, supervisors, and of course for the CEO who is counting the money afterwards. So I think it works quite easily. We will show you how, and we will also tell you how to install it. But before we start with all that, let me first introduce the family, because a family business deserves that quite well, doesn't it?
It does. Mahlo was founded by Dr. Heinz Mahlo back in the year 1945 and has developed into a quite well-known industrial enterprise located here in the south of Bavaria.
And meanwhile, it is in 3rd generation. And quite honestly, you can still feel that spirit of a family within all the aisles of Mahlo. So this is really a very good working together. It's fair, it's with respect, and it's with a lot of fun.
Yeah, we have in total approximately 250 employees. We call ourselves Malonese. Yeah? Sometimes this is a bit difficult when we ask for a visa, and then when we enter under nationality Malonese, but we consider ourselves as a strong community, and we all work together.
Very, very important. We are German, we are Bavaria, and we will remain like that, simply because we want to guarantee a certain quality. And this quality is the basement of our reputation. And this reputation is worth a lot for us and also for our customers, because at the end of the day, you have to count on the machines that we provide to you.
And the reputation is not at least based on our agency network. We have about 100 partners for the sales worldwide who are very active in the markets. You always have a partner to talk to who can talk with a high expertise about our equipment.
But we also have a lot of subsidiaries worldwide. We will show them to you at a later stage. And yeah, these partners that Thomas pointed out, we have them in 78 countries with agents and 40 with service agents. So if you are looking for somebody to help you with your Mahlo equipment, you don't have to wait until the Germans are ready to fly over. They are in many cases directly in front of your door.
Okay, now let's talk about our worldwide setup. We mentioned already, we are at the moment here in our headquarters in the south of Germany, in Bavaria. This is Saal. We have also a quite important subsidiary company in Italy who takes care of our sales activities and the service in Italy, especially because Italy for us a very important market, a very fashion-minded, and always the latest machines go there. Then we also have subsidiaries in Spain and in Belgium. From there we take care of our customers, Spanish and Portuguese speaking or French speaking.
Then of course, good morning to all our American visitors. They're also very important for us, not only because it's a very big country, also because there is a huge hub for the QMS business. Yeah, a lot of expertise.
And the latest foundation of Mahlo, this is our rep office in China, where we take care especially of our non-textile applications with the team there. And in the rest of China, we work with a partner who is exclusively working with Mahlo.
Our core competence, of course, is the systems for the online measuring, control, and optimization. But it is more than that. It's mainly the consultancy because we don't just supply machine, we supply solutions. And if your work is better with Mahlo, and then we've done everything right. But it all starts with a lot of questions because we want to customize the machines for your needs.
Yeah, Stefan mentioned already that we are mainly busy with running webs. What are the industries we are served? For sure, the textile industry. This is a very important factor for us, and especially there, Weft straightener. Mahlo is a synonym for Weft straighteners around the world. We have quite a lot of different types for each job, the right machine, but we will anyhow talk about those later onwards.
Process control is also in our DNA. Dr. Mahlo became actually a part of the textile industry by inventing the first process control for textile machinery, and this is how it all started. So ever since, and it's now 78 years or something like that, we are measuring and we are controlling and we are collecting data. So we have started with that even before the World Wide Web was invented.
Yeah, what we see on this page, these are our sensors, which are mainly stationary, used in the textile production lines, and then we also have traversing sensors to measure in cross direction, also on a running web, the most important parameters like air permeability, like area weight, like moisture, like thickness, like density, coating add-on, and so on. And this is an area where we nowadays also sell our equipment, not only in the textile industry, but also in the non-woven industry, the coating and converting industry, the extrusion of films, the extrusion coating, and also in the paper and into the tissue industry.
Yeah, but no matter if we're talking about textiles or the other industries, we all have the same challenges, and this is the quality. Quality is rising, money is always going down. We have to make the best out of it. We really have to have the best efficiency out of it. The nothing goes for free, but we have to provide the best quality with very good.
These are the challenges with which you are faced every day, because at the moment, after these unthinkable happenings in what's going on in Ukraine, for example, and the energy crisis which we all face, also for the future, we are sure that the prices for energy and resources will only know one way, and this is upwards. This is creating also so-called inflation everywhere. In most of the countries you have, because of the energy prices, high inflation rate. This means also the salaries have to go up in order to be able to still buy food and to do the necessary things. And on the same time, because there has to be a transition in the world's energy sector and so on, everybody is talking at the moment about sustainability, and this is especially for textile companies also an important factor which comes up more and more. Everybody wants to have green and
very much so. It's not just that we see it everywhere. We are in the focus. The textile industry is always in the focus of the media because of the pollution, because of the high energy consumption and so on. And this is also something that we have to focus on ourselves because we can save a lot of money, but also because we do have a responsibility towards the next generation, and we have to take that seriously.
And exactly, this is what we want to discuss through the next maybe 45 to 1 hour with you. This is your path to sustainability, because we believe that there is no excuse to waste any money.
No. And in general, we are focusing on the drying machines here because those drying machines, first of all, they are consuming most of the energy, most of the cost, and on the other side, they are also the bottleneck for the entire production. So they are very, very important for every wet finishing. And without any sensors, you don't have any eyes, no nose, no sensors. It's like a black box, and we want to open that black box for you to look inside and to make those processes which are happening inside more efficient and more transparent to you.
Yeah, when we want to talk about energy savings, we at first have to talk about what energy is, for example, going into such a stenter frame over the years. And we have here made our calculation based on 240 days. When we have a woven fabric, 150 grams heavy, 160 meter wide, the squeezing effect 75%. Desired.
The 75% is not a very low.
Yeah, exactly. So we believe that this can be run with 60 meters per minute. Then when you calculate how much moisture is running into this dryer, you can easily then calculate how much energy is necessary to evaporate all this water, which this kind of fabric is bringing into the machine. And then we come to a conclusion that around 5 million kilowatt hours per year are used inside such a stenter. For sure, this will depend also on the product mix and how it is operated, but this is a value which you have per year. We did indicate the kilowatt hours here because it is very difficult at the moment. The energy prices, we know they go up, but they are still very different, and we think you will have your own values and you can calculate this by yourself, how much money this is.
Exactly. Those tables you can find on our website under ROI calculator, and then you can punch in your individual numbers and you can see how it works for you.
Yeah. Okay. So if we just give you a number, in Germany at the moment we calculate with 9 cents per kilowatt hour for the industry. This will come then per year to 450,000 euros. If you calculate over the next 15-20 years with a certain inflation rate and cost increase, then you can imagine how much energy such a stenter frame is actually requiring through the lifetime.
and accordingly the savings that you can do by optimizing those things are really immense. And yeah, if you want to save money, you just don't just look at the energy. There's also the time, there's the energy, the electricity, and that of course is then summarizing in saving the money. And this is called the Mahlo process control. But it's not just that we, yeah.
Okay, sorry.
Yeah, since 1948, as we said before, we are actually measuring this processes of Mahlo. So this is something which is really in our DNA. This is something that we have done ever since Mahlo is existing. And so we really have a huge experience in this field.
Yeah, and since we are quite often traveling and meeting our customers, going into the workshops, we are still surprised how less machines are equipped with this kind of sensors who can help you to know what is actually going on in the machine and help you to optimize the input of resources and to optimize the input of energy in such a machine. And this is also the reason why we are now talking with you about
the process control.
The process control, yes.
And I just want to point out, if you follow the path of the process control, you see it's a very small part, and it is in this context is very, very important to understand that this standard, the drying machine, is the bottleneck. That means whatever you are doing in a wet process before that, bleaching, dyeing, mercerizing, scouring, whatever, that all has to be pushed through the standard. If you have blocked that standard because you haven't optimized it, you are blocking all the other machines as well. So this is not just affecting your standard, this is affecting your entire wet production unit. So the impact that a wrong tuning of this standard is having to your entire production is immense. So this is really why it's very, very well worth to look into that standard and to optimize every single parameter of it. And now we can go into it.
Now let's look into the stenter itself. The best possibility to save energy in the first place, this is to check how much air is thrown out via the exhaust duct on the stenter frame. Because this means you inside the stenter frame, you evaporate the water. It has to be removed. This is done via the exhaust fan and the exhaust duct. But very often, people throw air, dry air, out of the dryer, which still could carry much more moisture without influencing the drying process.
And the subject is, this air is hot air, this is warm air, this air is full of energy, and the energy is better used inside than outside of the stenter. And by putting that air out, you are not just losing a lot of hot air, which could be used inside. No, you also use those fans, which are having 7.5 kilowatt engines, motors, blowers, and though those are running on full throttle and really wasting your electricity on the same side, while they are putting that hot air outside that you would need inside. So you save twice if you optimize that process.
And therefore, we recommend to put the sensor who is measuring the exhaust humidity into the exhaust duct. This is our ZS12. It is a zirconium oxide based sensor with which we can measure how much moisture is in the exhaust air. And when we know this, we can set a target value which is good for the drying process without influencing the drying process itself. And automatically, the system is then capable of controlling the exhaust fan, the speed of the exhaust fan, so that only the amount of air is thrown out via the exhaust duct which is actually necessary. And if you are now going to increase, for example, the exhaust humidity from 8%, which means the air is nearly dry, to 14%, which is a regular good value for the most of the dryers, then you can save approximately 22% of energy.
Mm-hmm.
And the 8%, this is still on the higher side. Sometimes I see dryers where the thing is completely open and all the energy is leaving and going out.
Mm-hmm. but let's go and look inside the stenter and follow the path a little bit about what is happening if we are seeing it. So you see the sensor now.
It's in the exhaust duct. The sensor part is inside. Outside the black box is the electronics. Here you can see the sensor again. And now when he has finally stopped rotating, then we can see here is now the moisture which is going into the exhaust duct. It is passing by the sensor. The sensor will now know exactly how much moisture is there. And then this will be indicated. And as I mentioned before, with this information, we control the exhaust fan. Yeah. And if we take this example, you bring down the energy consumption on such a stenter frame from 5 million kilowatt hours to 3.9 kilowatt hours, which means the 22% of energy savings. If you multiply this with your energy cost, you have your savings.
And the return on investment on this invest is very, very high. So no, very low. So you get the investment very soon back if you invest in this little piece of equipment.
And like Stefan mentioned before, this you all can also check out by yourself on our web page on our ROE calculator. Yeah, just enter our website and enter under search ROE and you ROI, and then you will be already there. Yeah.
Okay, something that everybody knows, I think this is also where Mr. Mahlo started with, is the residual moisture. We all know that cotton is a hygroscopic fiber. Hygroscopic means that it pulls the moisture from the surface into the fiber, which means if you over dry a fabric, after a couple of hours, you will have back moisture of more or less 8% in the fiber of cotton. With that being said, over drying is not helping anything. It just wastes a lot of energy, and it is really ruining your overall output, because the stenter is running too slow, you're wasting too much energy, and the fabric is getting back the moisture anyway. And so you have to avoid that over dry just to increase the speed of your stenter and to get more production out of it. And by doing so, you are not only getting a better production and a higher production, you also have a much better absorbency and a better quality of the fabric at the end of the day.
Yeah, and because you can get more output from the stenter frame, you reduce this bottleneck which you have in your in your production, because you can run the stenter frame with the highest possible efficiency, and you have a, like Stefan said, a very even moisture content at the outlet, which is good for the following processes. Also here we have a short movie where you can see the electrodes where they are installed. Most of you have seen this, because this is not only on dryers, this you find also on cylinder dryers, you find it on weaving preparation machines, wherever moisture content needs to be measured, residual moisture content needs to be measured. This can help to optimize the process there. Yeah, now let's come to part number 3.
And this is the dwell time. If we talk about man-made fibers, of course, they need to have a certain fixation, and this fixation is clearly defined time period at a clearly defined temperature level. And for having a certain time in the stenter, you absolutely have to know where it starts. Otherwise, you cannot say when it stops. So this is also done by a lot of people just by the
because you do it all the time like this. You know, very often I go there, ask customers, and they tell me then, well, we run this with 25 meters because we always run it with 25 meters.
And here we have a sensor which is measuring the temperature of the surface of the fabric. It is not measuring the temperature of the chamber. It is really going on the surface of the fabric, and it is measuring this temperature, simply because at the beginning, when you evaporate the water out of the fabric, of course, this energy is used to get out the moisture. It is not used to heat up the fabric. Only once that moisture is gone, then the fabric starts to heat up. This is how you see it there on the red columns. And those red columns indicate the point when this heat setting temperature is reached. And then it's calculating automatically that time until the heat setting is finished. And there you go. So you always have exactly the right speed for that process as well. And again, here you optimize the speed of your stenter, you optimize the production of your entire wet finishing.
And you just have to enter the desired dwell time, which you for sure will know how much dwell time is necessary.
And off you go.
And then that's the full control is done. And with this, you can then avoid any safety margins. A lot of people run their stenter frame with high safety margins. They do not run it as fast as it would be possible because they say we want to be on the safe side. But this be on the safe side sometimes is also not very good for the touch, for the handle of the material. Yeah.
Let me tell you something about safety margins in general. Those safety margins are the biggest enemy in your production, simply because they have such a friendly touch. You think, okay, I'm running a little bit too slow, so nobody's going to blame me. But those safety margins, they are stealing so much money, so much production out of your production without even knowing it. So with that safety margin, it's not much. It's perhaps instead of 60 meters, you run 55 meters a minute. Yes, but it's 10% less production that you are getting out of the entire wet finishing. And this, gentlemen and ladies, is a huge number. Really, this is something that you really cannot leave unconsidered.
Yeah, and the 10% safety margin, which we put there on the slide, this is really on the low end. I have seen much more possibilities where we could go up with the speeds by about 20–25%. This is possible, and then you get a quite good output. And this also, when you have a higher output, has also a very good effect on the energy cost per running meter. We'll have in the end, this is what we said before, there is no excuse not to do this, because this is wherever heat setting is going on, you need in the end to do it. And I don't understand sometimes people when they say, let's wait and we can go on, because there are some costs involved to install such a system, because in the end, every week where something like this is not installed on the stenter, you're losing money. Yeah.
Let's go into the popcorn modus once again for the next movie. So here we see again the inside of the stenter, and you see where the sensors are pointing onto the fabric, and it is giving the information to the speed sensor of the stenter, and only it will always run in a way that your dwell time, your heat setting time is reached. Here you see it exactly with that small diagram that we have shown you before, where you have exactly the right time when the heat setting process is starting.
Yeah, that's now the next.
Yeah, let's interrupt quickly. I mean, we've talked about energy savings now for a long time. I would be very curious about the situation in your production. Do you have anybody who is responsible for the energy saving, something like an energy saving officer, an ESO in your company? Do you know something like that? So please give us a yes or give us a no.
Yeah, we just started this inquiry. So very simple question. Do you have such an energy saving officer, yes or no? Well, I think that we can already see the results. To my surprise, 56% of our participants say yes, there is such an energy officer in their company, and 44% says no. So what about you? Does this reflect also your experience, or are you surprised by these numbers?
I have to say that I'm a little bit surprised, but most likely this is now also because we had our topic, the energy hunters. So a lot of people who are having this already in their mind are now joining us in, but we see this very often that this is not always considered in such a way, but I'm happy. This seems maybe also this has developed in recent times because of the actual situation.
From my point of view, that shows that the textile industry is on the right track, and that many people have really taken already the right measures to go into the right direction. And I sincerely hope that what we are contributing here today might help them in finding additional ways to save energy and to make things a little bit better.
Perfect. In any case, it was a very interesting result.
Yep. Okay, let's carry on with the pick counter. This is about the density, and this is to ensure that you have a residual shrinkage which is constant. And
yeah, and I think this is nowadays, especially when it comes to knitted goods, it's a very important factor. All the suppliers of knitted fabrics will have to supply to their buyers. They will have to supply a fabric within an agreed residual shrinkage or below a certain residual shrinkage.
Also now, part of the quality, of course.
Yeah. And now we have to at first think about how residual shrinkage is happening. For sure, on one side, the material is done on the knitting machine, is made on the knitting machine. Afterwards, it goes through a lot of processes during the finishing, during dyeing, and so on. And this is let me check on the next slide. And then certain elongations are taken place or takes place inside the machines because you bring some mechanical stress to it.
Very diplomatic. I mean, if we talk about finishing, if we talk about dyeing, this is brutal force which is happening with the fabric. Irrespective if you have a long tube dyeing machine or if it has just a normal jet, whatever is done to that fabric is brutal force. This is really raping this fabric upwards and down, and therefore nothing stays as it was before. And this is why we actually have to do something afterwards to fix that, to bring that back again.
And the important information there is also that this elongation which takes place is not constant, because you have to dye your fabric on different dyeing machines. They have put different elongations onto the fabric. You have it on different knitting machines already. When you wind up the material on the knitting machine, you create inside each piece different tensions, different elongations, and these need to be compensated because otherwise, when you later on have this kind of variations in the product and the parts for making a t-shirt are cut out from different areas, then you will see that there will be different shrinkage potential there, and the residual shrinkage values will differ, and you will have a problem with your buyers.
And we are here to solve that problem.
Yeah, and how do we now overcome this? We overcome this with our sensor. This is an optical sensor which is installed at the entrance before the overfeed roller. At that point, we are measuring the incoming linear density, means the causes per inch or the picks per centimeter. Then, in this case now, we have an overfeed of about 25%. You go then onto the center frame at the center entrance, you overstretch the fabric, and you overfeed the material with 25%, and then you can reach 25 picks per centimeter, or better to express it in causes per inch. Yeah, and then normally this is all quite fine running if we assume that the initial density, linear density, is always staying the same. But
exactly.
Now,
this is what you mentioned before. It is not always the same. Sometimes we have an entanglement, sometimes we have a different machine which is stretching a little bit more, and then instead of 20, you all of a sudden have just 18.
And when you now measure with our sensor at the entrance of the stenter frame, 18 picks. Let's say it develops, or there's a piece and the next piece comes with 18 courses per inch, and you run the stenter frame constantly with 25% overfeed, then you can calculate by yourself. You will not end up with 25 picks or courses per inch, what you want, but you end up with 25 courses per inch. And this is exactly then our task, because we will then send out controls to the overfeeding system of the stenter frame and increase the overfeed to the 27% until we have again this 25 courses per inch or picks per centimeter. And with this kind of control, this intelligent feed-forward control, we have then the possibility already at the entrance of the stenter frame to ensure that what goes into the stenter frame is completely equal.
So long story cut short, if you have pick counter from Mahlo, you really have peace of mind that you always have the right density of your fabric,
and this,
no matter what happened with it before.
And this helps inside the dryer again when you have a heat setting and you have a material coming in with a constant density, constant weight. You will not have to do a lot of control up and down. The same for the residual moisture. It helps for the residual moisture. Even for the exhaust humidity control, you will have a more stable, output and also drying process inside the stenter frame. And therefore, we put this pick counter also in there because it's from our point of view, it's very important, especially when we talk about sustainability and saving costs. We believe that this is a big possibility. And I have to say, over the last 10 years, we have sold more than 1,800 of those systems to the industry, and most of them were retrofitted also.
But I mean, this is not the only advantage that you have with such a tool. I mean, density and weight, they are going side by side, and we all know that the knitted goods, they are sold by weight. So the weight plays a major role, and we have now the ability with our camera-based sensors at the exit to also get an indication about the weight directly after the stender without putting the samples to the lab. You have to press the button a little bit that we get further. Oh. I thought that we would still another sheet about that. Okay, so this is what we can provide as well. So this is part of this pick counter package on top of it.
Now I only can recommend all the companies today online who are active in the knitting industry to look into this matter, because this makes a difference.
It really does. Okay. So coming to another one, cylinder dryer. I mean, whenever you see cylinder dryers, you see a lot of steam, and if you have a stack of cylinders where there's no steam coming out, and then you know exactly there's a problem. The cylinder dryers, they're mainly designed according to the potential of continuous line, and continuous lines, they are designed according to one speed only, because the time for the washing and bleaching and so on is defined on the different compartments, and therefore also the cylinder dryers are actually defined for the highest weight and the highest speed, so they cannot be controlled in many ways. So
it's very important to know that those machines you cannot, like a stenter frame, make run faster or slower in order to control the residual moisture content with it. What you can do here, the only choice you have is to control the input of steam into the cylinders of the dryer.
In particular, if you have a very, very light fabric which is running over the entire stacks. And this is what we do. We are having the ability to switch on and switch off different stacks or even different cylinders to optimize the steam consumption for two reasons. First of all, steam consumption, of course, again, it's energy. It's money. But on the other side, and this is even more important, that you have a good absorbency afterwards, because if you have a fluctuation in the drying process, and then of course, you have a difference in the absorbency. If you just imagine you have an over-dried fabric at one stage with perhaps 2% or 4% residual moisture, and then again you have the 8%, that is already a delta of 50%. That the next step, the next process where you perhaps having any chemicals added in a pattern where a lot of chemicals are used at that step just because you had a problem with the cylinder dryer.
And now a few words about our system. How does it control the steam supply into the individual cylinders? At first, we need to know how much energy is required. How can we get this information? We have decided for ourselves that we are measuring the temperature of the condensate at the outlet of the dryers, yeah, because with the condensate temperature, you know exactly whether there is steam input required or whether there is enough steam still inside the material. So if, for example, now you're running a lighter weight fabric and a heavier weight fabric comes onto the first stack, immediately you will see that the condensate temperature will drop down. And this is then the moment where we open our proportional valves, or not our valves, we control the valves on the cylinder dryers, and with this we keep the condensate temperature always stable. At the end of the dryer, we are still having, additionally we have residual moisture sensor, and with this moisture sensor we will bring the absolute flat line to the right level. So whether we require now 6%, 8%, or 10%, depending on the fiber type and the process afterwards. But with this kind of system, we can ensure that at the end, like what Stefan said before, the fabric will leave the cylinder dryer with an absolutely homogeneous moisture content in length direction. So listing tailings in following dyeing processes will be much reduced, and this is also what a lot of our customers told us. Energy saving, very interested for them, but on the other hand, also the improved quality on within the following processes.
Every padding which is coming afterwards is really consuming so much more chemicals, dye stuff. If you don't have a level and optimized residual moisture at the cylinder dryers, and this is costing much more money than the steam, because as I said, this is really highly concentrated chemicals. This is really dye stuff which is paying a lot of money, and therefore this process really has to be controlled, not simply because of the steam. This is going, I mean, we are talking about 36% which can be saved here, but the following cost, they really count, and that also has to be looked after.
Yeah, here you have a few impressions how the systems look when they are installed. Yeah. I don't think, because of time reason, that we have to go through all this. And here is a summary of what we in the end already mentioned. One important thing is there, we have there this one value, this up to 36% savings of steam input into the or energy savings. And these are values which are not from us. These are values from our customers who had noted and stored the data about the steam input into the system before and after the installation. For sure, there are other. It depends always a little bit on the product mix, how much you can save. But it was up to 36% on several qualities. And this is not, as I said, not values from us.
They have a time calculation before atmoset and after atmoset, and the after atmoset is normally 36% less steam than before.
Yeah, and the other points on this slide, I think we have mentioned already when we explained the system.
Let's jump into the main part.
So we can now start with the residual distortions and about weft straightening itself. Yeah. Let's talk about this. We have put this also into this context of energy savings, because the cheapest energy is the energy which is not used in the end. And weft straightening is one of those topics. You need to supply straight fabric to your buyers. If you can't do it, and you recognize that there are still distortion in, you will have to go back, and this is creating a lot of costs.
If you are actually reprocess once, that means that the entire margin is lost already for that batch. If you are reprocessing twice, you are already in the red numbers. So this is really, from the economical point of view, a very, very important factor, as you said, that you don't have to cross a standard twice.
Yeah, exactly. And also, when we talk about Weft straightening machines, then we believe that a Weft straightener does not have to be designed only for the products you have at the moment, because we are in a fashion business, and therefore I believe Weft straightener has to be designed for the future in the end, so that you are safe on this, and because also in the future, in the end, you need to avoid these costs with reprocessing. Yeah? We talked with our customers and we said, what are they doing when they have this kind of problem that they have some distortions realized? Some of them, and this is the majority, they say they will run it a second time through the stenter frame, because and there they have to dip it. They have to wet it to get it corrected, and then they go through the stenter frame. It's a waste of money. Other possibility would be to accept for quite a big portion of the material a lower price, say a B quality, or I have mentioned, or we have mentioned this as a total loss. This is that you really cut those areas out where you have these distortions in, and in the end, these are the costs are coming from this, from all this reprocessing.
One of the big advantages of Mahlo is that we have a very, very wide range of different units. So we can adapt our model totally according to your needs. And this starts with the sensors.
Yeah, you tell us your product mix. This is something for sure we always need to talk with our clients. We need to understand what they want to do with such a machine. And after we understood this, and after we know what is the product mix, what are your plans for the future, then we can use our quite big portfolio of different measurement principles to select among those exactly the ones which fits especially for your needs. We do not have to do everything with a camera. We do not have to do everything with an optoelectronic scanner. We have quite a wide range. Yeah, and what we see here, we have on the left side the TK12. This is our optoelectronic sensor, which we consider to be the standard in straightening for the majority of the products. Then we have our CK15. It's a camera-based image scanner, which is available with reflected light, with transmitted light, with enforced light for special qualities. Then the two sensors, they can form together a complete new system, which we call then a hybrid system. And then you can use one sensor to check the fabric from one side, from the other you can check the others. And with this, you have in the end all possibilities.
Finally, we also have the line scanning for the pattern control system, where we are scanning like on a Xerox the surface of the fabric to detect the patterns. So if not the Weft and is running the show, but the pattern is ruling, and then this PCS line scan camera is the best solution for that.
Typical application would be, for example, lace fabric, where you have not a weft or a coastline going from one side to the other.
You also use it at shoe production or at airbags for technical textiles. So there are a lot of different things that can be counted.
And we have one more sensor. This is a CTK15, and this is when always we have very rough structures, like on the carpet industry, tufted or woven carpets,
or slow speed,
or very slow speeds. Then this camera type is also very useful. And like we mentioned before already, it's not only that we have these different principles, also within each principle we have different executions of our sensors with which we can adapt directly to your.
Should we run a little bit, because I think there are still a lot of different things ahead of us.
Now this we can maybe skip. Yeah.
What is also quite important is to understand that we have a very, very unfriendly situation at the dye houses. So we have a lot of dust, a lot of dirt, a lot of fluff. So it's not a very hostile situation, and therefore any traversing movement of the sensors is not really playing into the cards of the production. Yeah. How is it looking like in your production? Can you tell us about the situation? We don't collect the names, so but if you could just give us an indication if it is more like a hospital, or if it's a little bit dirty, or if it's really toxic. Just give us your voting right now.
I can see the results. So 25% of the participants say that or describe the situation in the finishing department as very clean. 67% say, well, it's filthy, and only 8% say it's toxic. So what about your experience?
Good, but that shows that we really have to take all the possible precautions to make sure that a sensor is not stuck somewhere and is not giving the information anymore. The Mahlo system is always having at least 4 sensors which are sitting side by side, up to 8 sensors which are counting constantly every single point of the fabric, and even if one sensor is not working, the others are compensating for that. So we really have a very, very safe operation in this, and this is important because the sensor, this is the eyes. Without the eyes we could not see, and without seeing we cannot control, and this is why we don't take any chance here by any moving part. We just make sure that we get the required information absolutely sure.
Okay, yes, and this was a clear decision within Mahlo also to go this way, to have our sensors at different positions in cross direction, because we get then every millisecond we get new values. This is constantly renewed. If we would let now the sensor, one sensor travel,
we have,
but not for this kind of application. For this kind of application, a fixed scanner, multiple scanning system is much better, because it has this as an you have this instantly, immediately there. If you would have one sensor and it's traversing in cross direction, as you can see on the left side, it takes too long time before you actually can react. If there is a bad sawing coming through, you have even more difficulty to get this whole thing sorted. Therefore, it was a clear decision from Mahlo to go this way, because it's simply the best.
Okay, let's go to the hardware. Same situation as we have it with the sensors, we also have it with the machines. We have something for everybody. So no matter if you have the commodities, or if you have a carpet or denim, or lightweight fabrics, or even some things that cannot be detected, we still can straighten it. We can straighten doglegs, we can straighten as distortion. So you tell us again, what is your problem, and we provide the solution.
Yeah, since we do not have so much time, we will not now introduce each of those sensor machines. We will have them during on our booth at the ITMA in Milan. So please come by, talk with us about your application, and then we can recommend whatever is possible. But one thing, because this is a really complete new development at Mahlo, this is I want to highlight now here, because we consider this as the absolute Champions League of Weft straightening. It is a specialist for knitted fabrics, for knits.
and you are the first to see it. Actually, this is the first time that we put it in public. That will be in display at the ITMA, the first time ever. This is a combination of different straightening principles and is making sure that really every single millimeter is coming out totally straight.
When you talk about the normal Weft straightener, which you all will have seen, I hope that most of you have seen, especially the Mahlo system, we have the scanning system always at the exit end. It detects there the distortion. It gives the distortion to our electronics, and from there, then the skew and the bow rollers are mounted, are moved to certain positions in order to shorten and to lengthen the fabric path in order to correct the value. But you need to have it at the end because you need to have a control loop. You cannot just put it on this machine on the top, yeah, and therefore you always need this at the end. But with our machine, we have now the possibility with the new machine, with what we call the Orthopac RXVMC, we have now the possibility that we have two parts. We have one straightener. On the left side, you can see it. It has the detection system at the entrance. As soon as the material is coming in, we can see the distortions. We can see the distortions, and based on the distortion which we see, we immediately can start from the first centimeter of the fabric arriving there, or of the new distortion. We can move the skew rollers and react on this. For sure, this is not a controlled loop. Therefore, we have on the other side, we have a second part of the Weft straightener, and there you can see there is also a skew and a bow roller and a detection system at the end. So this fine-tuned straightener, afterwards, he will then recognize any distortion which might be still in the fabric and give then a signal via the electronic systems to the skew and to the bow roller, and then you can be sure that the fabric is completely straightened right from the beginning.
It's actually two Weft straighteners in one.
Yeah. For sure, also this machine is equipped with our hydraulic system to move the skew and the bow rollers to the right positions. This is a very excellent system, and it's working in a linear system because the piston is moving the skew rollers directly there.
The momentum is unmatched. There is no way that any other system can create that momentum as a hydraulic system. You use hydraulic systems also with the caterpillars or with grains or with the heavy duty operations, and this is why this momentum here is really without any competition.
We also let our customer then the choice for an electric system, but also there we have optimized the whole kinematic of this drive so that the characteristics of our electric drive system is very close to it's not as good as the hydraulic, but it's close. It's much better than if you have just toothed bars, because then you always have some play involved. Here, with our system, there is no play involved. And a Weft straightener has constantly to move forward, backwards, has to do a constant job.
A lot of work. And this is something very, very important as well, because here we have worked together with the university in Germany, an algorithm which is taking the history of the fabric, and it's calculating the movements or the development of that distortion into the future. Yes, we can look into the future and we can predict how that distortion will develop. And with that knowledge, we don't have to move that far. We don't have to make so many movements if we know already how the distortion will develop in the future. And this gives us a clear competitive edge by correcting, because we are simply faster. If you know exactly what is happening up front, you can act up front and you can actually take the exact number of movement and of force to eliminate that distortion in time.
Yes, as I said, this was developed here together with our team and the University of Deggendorf.
Yep.
And it is what we call self-optimizing system. So it sees what is happening different speeds, different tension levels, and it will automatically react to it on the controller side. And this really makes a big difference on the straightening performance.
And next level will look into the lottery as well.
Okay, and now we have here we have now another system, and this is what we call our champion for the woven fabric. This is, in the end, as you can see here, this is a fusion of a pinwheel straightener with a roller type straightener. Both principles of correcting distortions, pinwheel and roller type, have certain disadvantages, but if you bring them together,
they only have advantages.
They only have advantages, and
it's the best out of two worlds.
This is what we have done on this machine. Yeah. Also, because of time restrictions, we cannot explain everything which is now
Milan
included, but we have this machine on the booth. We can show you this. You can see it in running condition. So please come by. And I think we then will be able to convince you.
We are here as well.
Okay, here you can see some installations. It's a quite huge machine, I have to say, for a Weft straightener, but it's also creating results which are especially on woven fabrics where you have irregular distortions, where all the roller type straighteners have their issues, or if you have just at the edges you have some distortions. This machine still, with the pinwheel and the roller type straightener, a passive and an active machine together can do the job. Yeah. And we have this also not only on stenter frames. Here you can see it now on a decatizing machine. This is a continuous decatizing at Segna in Italy, and this is a KD decatizer also in Segna. Okay.
When we talk about machines, we also have to talk about operating them, because a machine is only as good as the operator which is standing at the machine. And our operating concepts, they are very intuitive. We have spoken to a lot of operators and we have shared their knowledge and the experience in our applications, and therefore they normally like to work with our machines. They see exactly what is happening, what's going on. They know exactly which button to press, and therefore it's really fun to work with them. And for the shift managers and the production managers, they can see already from very far what is happening at that machine. You can see if the fabric is straight and if it's running in manual or in automotive modus. So it is really all the information is visible at a glance, which is also giving you a lot of information and a lot of advantages if you just pass by, because when an operator knows that he can be watched every time, he will do everything right, except and he will not wait until somebody is correcting him.
Yeah, and we have different levels of software. They differ mainly in the level of comfort of operating of the system. So there is no compromise when it comes to the evaluation of the signals and the control itself, but you have different possibilities how you can work and interact with the machine. You get a little bit more information. You have some help how to set up the machine and such things. And on top, then, when we now combine Weft straightener with process control, we also have then a version where you can see everything on one screen. It's no longer necessary to jump from one page to the other page or something. You can see all the important parameters during a stentering process on one screen, and it's a Mahlo screen.
In the cockpit, and there you have all the data available.
Yeah.
Talking about data management, these days, Internet of Things and Industry 4.0 are very, very important just to play with the data, to make it available, to create some transparency, optimizing processes, sharing data with other entities, perhaps also managing your die house and your operation from another point, from a home office or where else. And those are things that we support in every aspect with the right interfaces and with adjustments and with the M-log system that we have as a logging software where you can actually track down every centimeter of your fabric and see what has happened with it during the night shift, during the weekend. So you really have full transparency of what has happened, and you can share it with everybody who's interested in. So if somebody blames you that you haven't reached the right values, you can show him exactly what has happened. So you have an insurance for everything that might happen in your production. And as far as the interface is concerned, we have Profibus, Modbus, TCP, OPC, UA, everything. Just talk to us and we'll find out very soon.
All the regular interfaces are there, and so you just tell us what you require, and then we can provide the data external. What Stefan already emphasized is we are using the measured data for the online control, like what we showed before, but also we give you historical data, and the historical data, they are now then given in form of protocols. We have developed a complete new software where it's like a search engine, so the data are stored, and with this system you then have the possibility to create your own protocol, however it is required from your side. You can say, I want to see the data from the full shift, I want to see the data from one customer, delivered from one customer within a specific week. You can do whatever you like because all the data is available.
And it's got a very nice look and feel.
Yeah.
So then finally we have this cockpit, this is how we call it, where you have really all the data together in one screen, where you can collect the data from different lines in one thing, in one operations, where everything is really available for you, and therefore you can have that data available. Yeah, the benefit of data management, I think everybody knows that you have just a great performance, and you can detect anything that goes wrong in your production. Transparency is the keyword here, and teleservice, I think we do that since ages already. I think this is the standard. Meanwhile, with everything that is required to make your production line running again if something goes wrong.
And this is then also a very important aspect for when it comes to Mahlo. Mahlo has a worldwide service network. You always have persons in your country who you can call, who you can talk to, who can advise you, who can give you some recommendation how to get the best out of your machine. So these are always people who are not only looking into the service, they understand the textile industry, they understand the process, they understand our machine, they bring everything together, and they are local. And this is important because when you buy such a system, you're used to use it. You cannot allow that it is stopped for silly reasons. You cannot wait until somebody is coming from Germany, and therefore already since many decades, Mahlo has started to grow this network of service stations around the world.
And we train them constantly here. They will be here just prior to the ITMA, and I can't wait to see them again, because they really have a lot of stories to tell.
But this is really one of the important difference to all of the other suppliers in this area. Yeah.
We're coming to the end. Yes. So if you are hunting the energy holes in your production, look in every aspect. It will save you a lot of money by really detecting different fields where the energy is just escaping, and where you can put your thumb on. It is also improving your overall quality if you look into the processes really in detail in every aspect. And yeah, finally, you may look into the eyes of your children with a good feeling, because you have taken this sustainability really seriously and have not taken it just as one of the bold words of a marketing concept. It really pays.
Exactly, and therefore we only can invite you all to join us at our booth in ITMA. please note down the hall number 18, booth number C108. We are there. We are waiting for you. We are, after all this time with the COVID situation, social distancing, now we are really looking to meet all our customers. Come in. We have a nice bistro. We have
beer.
We have nice food there from Bavaria. And also we have all our equipment there. We can discuss whatever is on your agenda. We are just happy to receive you on our booth and to say welcome to us. Yeah. Okay, so what remains now is to say thank you for the attention. Like always, when we both talk about our equipment, we cannot stay within our time limits because, but you can be happy that it's just a few minutes now. So I have to say thank you, and it was a great pleasure for us to present our case.
If you want to have a little bit more information, and then you can easily visit us on our website. This is actually quite a good thing to have. We are also present in all the social media channels like LinkedIn, Facebook. We have a YouTube channel, and you can also find us on Instagram. If you liked it, just give us a thumb up. And if you have questions, our contact details will be shared later on, and then you can drop us a mail. It was a great pleasure for us to have you there once again. Thank you very much.
It's not yet over. Sorry to interrupt you, but you're really a great team.
And also thank you a lot for the VDMA for organizing this. Everything worked again.
Don't leave the studio now.
We are quite happy. Thank you.
Well, don't leave the studio now because we still want, you still have to answer some questions from our audience. But well, you already answered my first question, whether you will offer the visitors on your booth only water, but you already answered it. So there will be also some, I guess, some Bavarian beer.
Yes, local.
Okay.
Local from the bio brewery.
Perfect. Well, you're really very professional, not only when it comes to this studio setup, but also the way how you present. I mean, we have experienced many web talks here with our member companies, but I must say this was one of the best so far, really.
Thank you.
Well,
Boris, thank you very much. Yeah. And
the beers for free for you.
And will this will your comment also be in the video?
Yes, it will be in the video. There's no censorship in this regard.
Okay,
well,
thank you.
Let me ask, coming back to your presentation and to your offers also, as a finishing mill, when I want to retrofit my existing machine park with your process control systems, what would I have to take into consideration?
The good thing is, if you are considering a process control, what we are doing is we look into the subject, not only in terms of what suits you best. Is it residual moisture? Is it exhaust moisture? Is it the dwell time? We really look into your existing range, and then we can retrofit actually our process control in nearly every dryer on the market. But first of all, we don't just give you a process control. We really make sure that this process control is working and that it really also works for your production and your fabric.
So it would be best if you describe your process and what you intend to do, and send it to us, and then we will get in touch with you. We will discuss this in details with you, and then we'll give you an integration proposal how this can be done. And like Stefan said, we have done this with nearly all kind of finishing machines so far.
And you have seen us talking and talking and talking. Yes, this is one of our core competences, but we can also listen. And this is what we do when we are with customers. We listen. This is actually what we do most.
But this is not working on a webinar.
No, this is not. This is why this is why I'm saying it.
Yeah, and can really every unit be retrofitted with your systems, or are there any exceptions?
No, there is not really an exception where I can think of.
We are still searching for it. So challenge us. We would like to see it. And if you say, okay, this is just too old, we would take up that challenge and we would make even that old thing, which would belong to a museum, perhaps. We would love to see that running with an efficiency like a new machine.
Exactly.
That is our challenge, and we would take that.
And maybe it's also of interest for our listeners today, that the majority of our orders are for retrofits. You know, I mean, we deliver to the machine makers, and then they include it into complete new lines. But the majority of our turnover is created by the retrofit of such systems into existing lines. A lot of people, they start and they say, maybe we don't need such system, maybe we can work without it. And then after half year, after 1 year, having such a machine in operation, they realize it would be better to have an optimized and really good process control and a straightening system on such a machine. And this is then our chance to discuss and to give them the tailor-made solutions.
You can't imagine how little money is needed to really pimp up your range, to really make a high performance range again out of that piece of metal that you are calling a dryer at the moment. It is really not much, neither from the investment in terms of money and also not in terms of the efforts that you have to make to get that installed. So really, this is always worth consideration, especially for those old ladies that you have in production.
Yeah.
Okay. And my last question, well, if there is a problem or challenge with one of your systems in the production process, should the customer contact, well, you mentioned your network in the country, and is it always possible that this person can find a solution, or is there also kind of remote support from your side?
This is both possible.
Yes.
I mean, we normally, our specialists in the individual countries are very well trained on our equipment, and most of the equipment they even install, they even commission, they do the whole thing. They can do it. But for sure, when now new machines are developed here, new sensors are created, when they come the first time into the country, then for sure, then also our team from here will go there, will support it. But already during the commissioning phase, we teach our local team. So I would say that 95, maybe even a higher percentage of all service inquiries can be handled by the local team.
Perfect.
Very much so.
Nico, I think we have received also a few questions from the audience.
Yeah, that's true. I think you already answered some questions with the old machines, whether it is possible to retrofit them. There is another question. In case of wider width stenters for bed linen with dwell time controller, how crucial is it to consider also pyrometers across the widths in few chambers? Will it help the resultant?
Yep, this is absolutely a valid question, and it's a blame on me that I haven't mentioned it early on. Of course, this is a vital thing to see whether the drying process is really also taking place over the entire width. I mean, if we are talking about 3.2 meters, and then it can be that the distribution of the heat over the entire width is not always regular, and with that we can check that, and you can have a very good indication about what is happening inside your stender, and then you will realize if there might be a problem before you have a fabric which is destroyed, something like that.
Yes, and the same applies also for the residual moisture control. We also have not only this possibility to measure the moisture content, the lowest moisture content, we also can indicate left, center, and right moisture content, which is again sometimes then important for afterwards padding a process and such things. Yeah.
We have a called PEP system.
Exactly.
Okay. Another question is, this person seems to have some doubts. It seems to me difficult to control drying cylinders because of the masses involved. It is much more difficult than in a stenter. Does it really work?
It works perfect. I only can say we can give you reference installations, but also one thing I have to mention. For sure, you can not only have one valve at the end, which you control with the residual sensor. You need to do what I tried to explain with the condensate temperature, and you have not only one control loop. You need to separate your cylinder dryer into individual stacks with individual proportional or on-off valves. This is necessary. And then it works perfect. We have, as I said, we have many customers, and especially with the Atmoset SMT, we have a lot of customers who bought one, who bought two systems, and afterwards they have 10 and more systems installed.
I can fully understand why somebody thinks that that might be a problem with these cylinder dryers, simply because the steel or the stainless steel of those cylinders, it is not changing the temperature very quickly. And this is why we have taken that surplus of the condensate, because the temperature of the water, that can be measured. And this is an indication. And this is actually then the reason why our system works. It is because it's a Mahlo, of course, but also because we have taken that water, which is fluctuating much easier in terms of the temperature than the steel frame of those cylinders. So don't be misguided by that huge installation of cylinders which are not quickly changing the temperature. We are not measuring the temperature of the cylinders, we are measuring the temperature of the condensate of the water. And this is then the reason why it's working that easily and why we can control it. We wouldn't be able to control the temperature of the cylinder or of the chrome or the stainless steel or the steel. That would not work. But by that temperature of the condensate pots, this is why it is actually then all of a sudden making a very, very good system.
Yes.
Okay, another question. Can you also recommend peak density counter to an open width compactor in felt type?
Basically, we have also there quite a number of installations. Because in the end, it's the same inlet scenario like on the center frame. It's open width. You go underneath. You have the overfeed roller. You overstretch before you go there to get those things in. Yes, it's possible. But on I would say that at first it should be installed on the center frame, because a lot of material goes over the center frame. It can be equalized there already, and then it comes to the center to the open width compacting machine already with a very equal density, and then you can use and utilize the open width compactor with a better efficiency and also with higher speeds.
Okay, to finalize it, I would like to quote a comment that was written here. Excellent presentation by both of you. I'm sure this session is the need of the hour. I think you done an excellent job.
Thank you.
Thank you.
It's a pleasure.
Means a lot to me, to us.
Yes, I think so. There was a lot of commitment and also conviction involved in your presentation, and I think you're really a good team to present all these innovations and advantages for the textile industry. Perfect.
Yeah.
So,
thank you, Boris.
And now we wait for ITMA to do it in the live performance. And
yes.
I was also live now here. Sorry.
It's always better to meet in person, of course, which is possible. I think you should now be able to see my screen. So as mentioned already, you will find the booth of Mahlo in Hall 18, C108. So you're mostly welcome to visit them and also to discuss your issues and topics directly. As I mentioned already in the other web talks, here under this link, you can also buy your visitor badge if you have not done it already. And today, the ITMA show update was published from ITMA services, from the organizer. You will get this presentation later on, and if you're not in their distribution list, you will get this update as well. We as VDMA, we will continue to support our members. The next web talk will take place on the 17th of May with Lindauer Donnier. So it's about weaving machines and their production technologies for high-end fabrics. But we do not only use this channel or this tool here as a web talk, we also have produced 3 videos at the moment, which are published here in the playlist of VDMA. You will find the link here also in this presentation, and also from the other members, you will find further information, statements, a kind of preview in the run-up to ITMA on our platform of Industry Arena. So please feel free to have a look here and to get further inspiration also, and to prepare yourself for your visit in Milan. Well, thank you very much also to all of you staying with us, also to Thomas and Stefan for this great presentation. And we will see us next week here online again. And as I mentioned at the beginning, you will get the presentation in about 1 hour. And then you can also get in touch with Thomas and Stefan directly if you have any specific inquiry. Thank you. So see you next time. Bye-bye.
Thanks a lot.
Thank you. Bye.
Bye.